Yep. Hi. Can everyone see my screen?
Yes, very clearly.
Hi. So my name is Tommy. I'm one of the open source developers under the Code team as well, and I mostly contribute to the Kubeflow project. And has everyone have access to their main dashboard over here?
The number of yeses.
Thanks. So we'll get started. So I think everyone have seen this dashboard from the last few sessions. So I just give a quick overview. So on the left-hand panel, you have different navigations on the different components of the Kubeflow. So the first one is the home. So you can see the home page over here, where you can find shortcuts to like several tutorials. The notebook you have just created, pipelines you have uploaded, and the executions of every pipeline run you have done in this cluster. And then on this side, you can see like a list of common documentation on how to get started with Kubeflow. And over here, you can see the activity tab. And when you click on here, you can see the events you have done on this cluster. So if you look at what I did is I ran a few sample experiment using the MSNet. So those are all recorded over here, and you can see like what runs the sets in this case. And if you see any error, you can also find the logs from here as well.
Just a quick thing, like if somebody needs a dashboard and they don't have a deployment right and they want to follow along, just post it in the chat and we can give you IDs to the clusters which we deployed before. So yeah, if you need one, just ping there and then the team can ping you, including mine, the dashboards which you can use.
Thanks, Animesh. So I think we'll go ahead and see the next tab. So the next tab is pipelines. I think everyone have seen in Animesh sessions. In the pipeline, you could execute pipelines that have already been uploaded.
Hey, Tommy, can you maybe I'm sorry to interrupt you, just wait for a couple of minutes and let's see,
right,
probably
no problem.
Who needs a dashboard to have a dashboard before you go through this.
Right, so there are two people asking, yep, at least.
Okay, let me get mine, which I deployed. I definitely tested the pipeline. So I was going through in the background, right? So I'm not sure if, so this is one. Christian or Andrew or Vaishang. Christian, okay, you got yours. So there are two more available for the two who requested. And if more people request, let us know. So maybe Naushad, you can grab the first one. Joe, you can grab the second. Okay, cool. And Naushad, if there are issues with that deployment, let us know. We can ping you another dashboard.
Right, thanks. So is everyone have access to their dashboard?
Raise your hands. Here's a chance. We still have 4 or 5 dashboards available. People need it.
Oh.
Arthur, okay.
All right.
Maybe Vaishang or Andrew?
Yeah, Weishang has posted one. So Arthur can take that one, right?
Yeah.
And so there's one spare from Andrew now, if anyone wants it.
Yeah, so anyone else wants another dashboard or we're good?
Okay, so Andrew's is still spare. Okay, good. All right.
Cool. Okay. Please go ahead, Tom.
Right, thanks. So to just so we went over like the home page. You can see like the main dashboard and the activity. And from the left-hand panel, you can select different components from the Kubeflow stack. So the first one we'll go over is the pipelines. So for the pipeline, you will first see like initial demo pipeline we have created over here. It's called FlipCoins. What this pipeline do is it will run a container to flip either heads or tails. if it's head, then we go over like this container to do a random number generator between a range of like I think 10 to 15. If it's tail, it's going over like 1 to 10, and then based on that number, we'll do a print statement basing on those conditions. So in order to do a smoke test, you could just click on create one button over here. You could use the default settings, and under experiment, you could pick defaults and click on use this experiment. And the service account is optional, so for this tutorial, we'll just leave it blank and click on start. So you will redirect to like a list of run page on the history runs you have. And the first one is the pipeline you have executed right now. Over here, you're able to see the pipeline is start running. And this is like the running icons. Like you see, it's similar to the refresh icon here. And when you click on there, you will see a tab opens with multiple informations. Like the events will show you the Kubernetes events on this particular pod. The pod will show you the pod spec of this container. And the logs will show you like you flip the coin either heads or tails. Since this one have no volume, you won't able to see any volume amounts. And then once the container is finished, you will able to see what are the output artifacts. And over here, you could see there's a hyperlink on the outputs, and you could click on here. It will direct you to the artifacts page, which is like the third tab over here as well. And in this artifacts page, we will show you like what type of the output is. Since we're using the default metadata writers, there will be no type here for tectons. And then underneath, you see the URI for the artifacts you have generated. So you click on this link, you're able to see it created a minimal bucket link that show you what is your artifacts in a text file. So in this case, you can see the text file is heads. And then once you like finish checking the overviews, you can also check on the Lineage Explorer. In this case, you can see the Lineage Explorer saying that the flip coins created the output. And you can refresh the page using the reset buttons. And then we will go back and see the pipeline. So since this pipeline is running with conditions, so if one of the conditions didn't met, it will show you like why this container is not executed. And for the container that do get executed, it will show you like condition has complete in this case. So is everyone able to execute a pipeline in this case?
A few yeses.
Oh, that's good.
A lot of SS. Good.
Anyone have any questions at this point? Okay, I think that seems great. So for more details on how the artifacts and executions work, we will cover that in tomorrow's sessions. But for now, you could see each pipeline, it will always generate the output parameter as the artifacts, and you could check what kind of execution they done in the execution tab. And you could also like archive the pipeline you don't want in the archive page. So any question related to the pipelines?
There's a question in the chat.
So for the notebook, we're going to do next, right? So the next section is going to, the next I'm going to cover is the notebook server, where like the actual hands-on is okay. Doing so once you click on the notebook server, it should redirect you to the Jupyter Notebook server page. And over here, if you don't see any server, I mean, if you haven't created any server, you could click on add new server. And then if you don't see any namespace over here, then you probably want to tap on the Kubeflow bar and select the anonymous user. This way it will fill up the namespace for you in this case. And then for the name, you just put anything lowercase. So because I already have demo, so I have to do like -2 or something like that. And you could pick an image over here. These are all like TensorFlow based image that's built for the Kubeflow Jupyter server. But you can also like use your own custom image as well. And then for the CPU and RAM, we will just use the default with like 0.5 virtual CPU and 1 GB of memory. And we will use like a persistent volume to persist our bootload in this notebook. So once you're done with everything, then we'll click on the launch button. Then it'll probably show you this icon saying the Jupyter server is provisioning. So once the server is provisioned, you're able to see like the like what I did for the first notebook. It will say running, and the connect button should be able to click. And once you click on the connect button, you should be able to see your Jupyter server page. So I think I will pause over here. So anyone have any question with creating the server?
So there's questions in the chat. Someone doesn't see any pipelines ATM, which apparently you saw.
Pipeline ATM.
Scott said that because so he's saying, is it normal for me not to see what you see? So what he was seeing wasn't the same as what you saw.
What are you seeing, Scott?
Do you want to share your screen, Scott? At the moment.
Hi. Yeah, I can share my screen. Sorry to cause trouble here.
No problem.
I'm just curious. I have everything up and running. Let's see. Oh, I do have something now. Maybe it took a while to load. Is this? I guess I was looking at the day one hands-on bits in the repo, and I loaded up the notebook successfully, and I saw what Tommy was showing, but I'm not sure that I should have anything else here. Maybe this is normal.
Yeah, like I think the version you deploy is using the Argo backend, so it's a little bit different from what we show here.
Okay.
But yeah, that's what you're supposed to see in this case.
Okay. Okay, great. You I guess I was about a minute or two behind, and I just wasn't sure if I. Okay, I'll stop sharing now. And sorry.
Right, thanks.
Thanks for helping.
No problem.
There was some other items about memory limits, I think. CPU memory and CPU max limits. There was a question. And then mostly, yeah.
We haven't, I mean, not that we are aware of, right? I mean, we obviously we haven't stress tested, to figure out what the limits are, but it probably depends, on the underlying infrastructure, right?
Okay.
I mean, in general, Kubeflow as such wouldn't expose any limitation, right, which is not being propagated from the Kubernetes perspective, right? And so far, I mean, if you see Kubernetes as such, right, I mean, it's being used for all kinds of workloads with all sorts of capacities around CPUs and memory, right? So we can try and find if there is a max limit they impose, but not something, I'm aware of offhand.
I think I can add to this. So make sure that when you ask for a particular number of resources, when you launch the notebook, your cluster is actually configured to provide it. For example, if you want to have 4 CPUs, but you only have small nodes running, then it's not going to work, obviously, because you don't have a lot of CPUs provisioned, right? So just be aware of what the cluster can provide, and don't ask for more, because in that case, you're going to get errors, you know. But half a CPU is pretty reasonable, because the cluster is, these are small clusters, right? But, you know, so you can always get half a CPU. And if you need like 8 CPUs, ask your cluster administrator to make sure that you have large nodes that can provide those 8 CPUs to you.
Yeah, thanks, Igor. I think that totally makes sense. And similarly, right, I mean, if you're running on GPUs, right, you have to ensure that the underlying Kubernetes cluster has added GPUs as resources, and it's available in that particular namespace in which you're launching that notebook. Yeah.
There's another question to make use of Knative, Selden, etc. I'm assuming it's through the CLI for APIs, or APIs instead of the dashboard.
So you're talking about KF serving, right? So or Selden, right? So specifically in the context of KF serving, yes, it's a native CLI experience if you're using kubectl to deploy models or manage them. There is a Python SDK which you can use through notebooks. So I showed a bit of that earlier in the morning, right? And tomorrow, you know, I believe Tommy will go through that notebook end to end. Plus, you know, you can use Kubeflow pipelines as well, right, to launch models on KF serving. That was one of the demos I showed earlier in the day. But there is no native UI for KF serving. We are currently, you know, exploring it within IBM, right? And if we do see, you know, it shapes out well, then probably, you know, we will move that UI in the open source. Yeah.
Right, thanks, Animesh. So let's check again. So is everyone have access to like their Jupyter server? If everyone have access, then we could go ahead and go to the Kubeflow Dojo. And under today's sections, you could click on the hands-on notebook. And here should also show you the instruction on how to how to create a new Jupyter server. And at the end, you could clone this repository, which contains this lightweighted components IPython notebook. So I did it over here earlier. So once you have this notebook, you will go back to your Jupyter server page. A simple way is just to drag it over here and click on upload. Or you could also click on the upload buttons over here and select it from your file system. So I'm going to cancel this one. And once you have the notebook uploaded, then you could click on the notebook. This should able to bring you to the Jupyter page. And the first page is explaining what this notebook is going to do. So this notebook is a lightweighted Python component where you could run some simple Python function here. And at the end, we will compile those functions into a Kubeflow pipelines and execute it on the same cluster. So first, we need to execute the first cell to install the dependencies. So when you run it for the first time, you will first update the pip, and then also like install NumPy, TensorFlow, and KFP Tecton SDK. And once you've finished running, then we need to restart the kernel because there's some package conflicts during the install. So we have to restart the kernels and let the kernel reload with the latest dependencies. And once you've done that, then we could continue to execute the second cell, which it import the KFP package. And then on the third cell, we're going to define and add functions. It's just a simple Python functions. And once you define the function, we could convert it into a Kubeflow pipeline functions using the components function to container ops. So we can execute that as well. And this is a very simple function. So we're going to show you like a bit more advanced function and how you could use multiple imports and installing packages as a subprocess as well. So for this function, we could execute this. And what this is going to do is first, it will create a subprocesses to install TensorFlow 1.8. After that, it will create a subfunctions for the divisions. And at the end, we define some metadata and metrics and output it as part of the functions. So we could test these functions by just running on inside this particular Jupyter notebook. So we could run this. So you can see it will take a while because it tried to overwrite the TensorFlow versions behind the scenes. And once it's finished doing that, then we will do division using NumPy. So probably will take about a minute or so because it's kind of overwriting the whole library, the TensorFlow library. And then once you finish, you'll be able to see this output. And this function could also convert it to container op as well. So we could going to do that here. So once we have all the Python function converted to the Kubeflow pipeline container ops, then we could define a pipeline that put them in a sequential order. So in this case, we will have like 3 input parameters called ABC. And the pipeline is first to add A, which is 7 to 4, and then divide the output of that to B, which is 8. And lastly, we add the quotients to C, which is 17. So let's go ahead and define the pipelines. And then you could also define any arguments to override it. But in this case, we'll just use the same input parameters. And you could omit any parameters to just use the default one that you defined above. And because we're already running this notebook inside Kubeflow pipeline, so we don't have to specify a host. But you want to trigger this on a remote cluster, then you have to define which cluster you want to run this pipeline on. And in this case, we're using the Tecton backend, so we use the Tecton clients to execute this pipeline. So let's go ahead and run this. It will show you like the experiment link and the run link for your pipelines. For those who install with Argos, you could use the client commands below, which it will trigger with the Argo workflow. So once we finish execute, we could click on the run links over here. It will direct you to a new page showing you like the pipeline diagrams. So in this case, you can see the input is A, and because we +4, so you could see the output is 11. And then in this case, we have the 11 as the input, we divided by 8. Because it would, because you remember this function is going to install TensorFlow in the background, so it will take a while to first install TensorFlow and then do the divisions. And you could see like because our base image is 1.11, so it could override whatever package you have inside the image, and then execute the functions you want. So I think once we finish executing, it should show you the output. In this case, the quotient should be 1, and remainder should be 3. And then lastly, we just add like 1 to 17, so we get the final output as 18. And you can also check like all these input outputs using the Lineage Explorer as well. And that is like the demo of the notebooks. Any question regarding to this?
Yeah, there's quite a few questions starting backwards. Okay, so somebody's answered. Volker says restart the kernel for the module. Okay, so
Yeah.
okay, go ahead.
Yeah. I think for that, I think we kind of missed one step of the instruction. So I think for the Kubeflow TensorFlow notebook, we're sort of overriding some packages that's already inside the image. So that's why we have to restart the kernel for it to reload what we have for the KFP Tecton library. So I would say we will update this notebook with the extra instructions to do.
Okay, and then there's another point that someone's notebook has 4 CPUs and 4 gigabytes RAM, but running much slower than yours. Tell me.
So which step are you running slower?
I think the answer to that was restart the kernel and rerun. You know, I think.
Oh, as well. So it's the restart the kernel is for module not found and for running slow.
I mean, running slow, it kind of depends on, there's few factors to that. So it could be networking issues. It could be something went wrong with your Kubernetes cluster. But most of the time, you restarting the kernel should be able to give your kernel a refresh. So it will kill any process running in the background and then just restart everything new.
I mean, that's, you know, one of the key things with, you know, Jupyter notebooks, where, you know, if you're bundling 2 heavy libraries into a container, I mean, TensorFlow libraries, you know, are pretty heavy in terms of, you know, if you're bundling the whole framework as part of that. So you do tend to see, you know, a bit of that. So that, you know, essentially implies, yes, that somehow, I mean, ideally, yes, the first requirement is, you know, having that write capacity to be able to run that notebook image. And B, the second thing is at times, you know, restarting the kernel. If you are already using, for example, something like Jupyter Hub, you will see this happening, you know, multiple times. I mean, there has been, you know, not a lot of notoriety on the Jupyter Hub side for this. Unfortunately, you know, this current implementation avoids, I would say, you know, the issues like that are 70% lower than what you would see if you're running Jupyter Notebook with the same size image with the same capacity requirement. So, yeah.
Tommy, could you possibly is there a way to list the lightweight components that you've defined, like add and div mod, so that we can see them sort of to reuse them?
So for lightweight component, it's just any Python function you could define. So in this case, let's say we take the app for examples, you could just define like a Python functions with like inputs parameters. It's better to give them a type so they know like what is to expect for the inputs. And then you also need to say what type you want it to be the output. And then at the end, you just call a return statement, and this will act as your pipeline output steps. So it could be any Python function.
So after you've done that work and made that available to people, how can they find out which functions you've made available?
So you mean like you define like a Python function and you want to host it somewhere else?
Not so much host it somewhere else, but if I've got another workbook where a notebook that I want to use that function from, is there a way I can figure out which functions have been made available for me?
So I don't think any function is part of the KFP SDK, but there's a list of components you could find from the Kubeflow website. So you go to the Kubeflow pipelines on the GitHub page. There's a components directory, and you click on that. There's a list of available components, and some of them are just coded with like pure Python code, right? So I think, let's see. I think one of the examples, maybe from Kubeflow. Maybe.
The reason I ask is because we have some common functions in shared notebooks, and we're not having a lot of joy getting our shared notebooks being imported into Kubeflow. But if we can use these functions in this way, people can do stuff with them. And then if we can find out what functions the team have made available to each other, they can benefit from the work the others have done.
So maybe the question, Tommy, is can you share operations? Like if I publish a pipeline and it has, I don't know, an addition operation, container operation, can other tenants of the Kubeflow use that?
So by default,
That is a better way to ask the question. Yes.
so by default, Kubeflow pipeline currently allows you to upload pipelines if you don't have, and currently, the default version doesn't have namespace isolation. So that means, whatever you upload is available to everyone else, right? It doesn't break it down in terms of, if you're thinking like, component registry, which is shared across, and you can just pick and choose components from there, right? So currently, neither the dashboard nor the API gives you that option. What you see is a registry of pipelines, an API for that, a UI for that. And that is by default shared across namespaces. With the multi-user pipelines coming in place, then, the uploaded pipelines will still, the default option will be there available to everyone. But when you are running it, you're running it in your own namespace. Now, can it be broken down at a components level? So there is, again, an internal project which we are working on, with the hope of moving it out in the open source soon as well, which extends that and gives an option to create a components registry with an APIs, right? So you can actually discover existing components and you can publish them to be part of a main catalog. And then, take it from a component perspective that, these are the components I want to use in a pipeline and start from a bottoms up approach, right? So if you're looking more from a dashboard perspective.
That's great. Thanks, Animesh.
Okay, thank you.
And there's another question in the chat explaining how the Lineage Explorer graph works.
Oh, yeah, I could go ahead and show you. So I think, let's say we take this this run as examples. So under each run over here, you could click on the ML metadata, and you could see like what are the inputs and outputs and the artifacts ID. Let's say like in the middle task, you can see like there's one input, but there's like 4 different outputs for this like task. And you want to see like how these tasks are being used, then you could click on like one of the executions. We could pick this one, and then you could pick let's say because we used the quotients over here, so we could click on this one. You can see like the quotient is being used by add2, and it's produced by my diff bot. And you could click around on other artifacts and see like how they get generated. So if you click on like the first outputs over here, you could see this output is generated by add, but it's used by my diff mod. And then you could also see like my diff mod will going to produce 4 different artifacts, but not all of them will be used, right? You click on, let's say, the remainder, which is not being used in this pipeline, then it will just show you it will just being produced by my diff mod, but it never get used by any other component. Is that answer your questions?
Igor, that was you who asked the question, right?
Yeah, he says yes. Yeah.
Thanks.
All right, thanks. So any question regarding to the notebook?
Hi, Tommy. Quick question here.
Yes.
So look like the integration with the Kubeflow pipeline is that after you run the cell and you generate the YAML, you get a link to deploy it directly onto the pipeline. So is there other feature that from the integration? For instance, if I were to run the same notebook on somewhere else, let's say on my local workstation, then I have to save the YAML and then upload the YAML. Right?
I mean, there's few different ways you could do it. So what I mentioned over here with the host is that if you run this notebook in your local machines, you could actually just let's say give this host address over here with the pipelines, right? Like /pipelines, and then execute it this way as well. So you could also execute like the pipeline in a remote machine, or there's other ways you could do the pipeline where we're going to introduce in like tomorrow's sessions. But you want to take a look at now, you could go on the KFP Tecton repository, and you can click on the samples. On the very first section, you could see there's a KFP Tecton user guide. You click on this, you will see there's a different ways you could compile pipelines, upload pipelines, and running pipelines. And you it could let's say you could compile using either like the SDK or the CLI, right? So there's multiple ways to do it. And what we've done today is just using a the Python SDK, where we use the Tecton client to compile and execute behind the scenes. Yeah.
Right. So those are independent of the Jupyter Notebook, right? So what I was asking is that if the point of running the Jupyter Notebook on the Kubeflow cluster is to have that integration.
Yeah. So you run, let's say you run on the Jupyter Notebook, right? So you don't have to specify the host. You could just put none for the host. So behind the scene, it would just go to the notebook's RBAC access, and then it will see this user have permission to execute notebook on this cluster. So you could just run it without giving any credentials or like endpoints to like this particular cluster.
Okay, got it.
Yeah.
Thanks, Alan.
Does anyone want to answer Falk's question, or do you need him to read it out? Or
how
let me see.
flexible is this pipeline concept? Can I use this to build inference pipelines? For example, for a complex AI agent that interacts, continually learns, let's say that agent is 20 internal AI component like speech detection, dialogue management. I mean, you might have to explain it a bit more, Fog, right? But inference pipeline is, I mean, the definition of an inference pipeline is different, right? I mean, so this is, can you glue together multiple components, right, which you are mentioning around, you know, speech detection, dialogue management, movement planning, etc. Definitely, I mean, as I mentioned, like Watson speech to text team, right, within IBM is using it heavily with throughout, you know, they have created their own custom components to do a lot of the custom jobs, right? When you like inference pipelines, or, you know, what we call, you know, the model serving graphs, they're more in the context of chaining, you know, prediction request across models, right? So technically, you know, can you put something like that using KP? Yes, but you know, for that, you probably would want to wait for, you know, there's a feature which we are working on getting it added in KF serving, which is, you know, the concept of multi-model graphs or inference pipelines, right, which allows you to then specify, right, which model to be called in which sequence, and the output of which model needs to be taken to the different model. So it's a sort of a difference between a functional and imperative programming, I think, or declarative, right? Imperative versus declarative, right? So pipelines is more, you know, functional. Do this, do this, do this, do this. When we are designing these inference pipelines in KF serving, it's more like, this is my model, you know, graph infrastructure, right? So these are the models, and this is how I want that sequence of incoming traffic requests to follow, right? Instead of do this. So a slight shift. Yeah, I don't know whether that answers your question, right? But it probably also is, you know, the way I interpret the word inference pipeline is probably different. Thanks, Morgan. If you're really interested in that, I would strongly encourage to start looking at KF serving, right? I mean, you know, pretty soon, you know, we will be launching, you know, what we call, you know, multi-model graphs, where some people want to call it inference pipelines even within our group. But that's an upcoming feature, you know, going to come out in KF serving soon. Okay. Go ahead, Tommy.
All right. So is there any question with the notebook If not, we could move on to the next sections on Kubeflow.
How long is the next session?
I mean, sorry, next components, but it should be pretty fast. So
Okay.
we are going to just give a quick look on the cat tip.
Okay. Great.
So you click on the main Kubeflow dashboard, the left panel. The fourth one is the cat tip, which is the hyperparameter optimizations. Once you click on here, you should be able to see there's two options you could do. One is hyperparameter tuning for like regular machine learning work, and your architecture search, which is more aimed for reinforcement learning. And you want to learn more about like the concept behind it, you could look at how to use it with the Kubeflow documentations, or you could go ahead and visit the GitHub and see like what kind of experiment you want to run, etc. So just for today's demo, we'll just go ahead and submit a default hyperparameter tuning. So you could click on this tab and it will show you like HP, and you could click on HP and then you will see two tabs for submit and monitor. So first we go to the submit tab. Over here you could input like a plain YAML files for running catip. So those example YAML files you could also find from GitHub. But an easier way you could do is click on the parameters, where you could have a form view to input any parameter you want for running this catip experiment. So in this case, I already have something read before, so I'm just going to rename this for random experiment 2. And namespace will be run based on the user namespace. And then here we would pick on like the how many trials we want to run. So in this case, by default, we run at least 3 trials. Run 3 parallel trials, and maximum trial we're going to run is 12. And we're only going to retry the same trial 3 times at max. And the objective of this run is to maximize the accuracy. So we want to get at least 0.99 accuracy in this case. And then we'll just use a simple random search for the hyperparameter optimizations. And like these are the parameters we would use, like the LRs, the number of layers, and the optimizer. And the parameter you search, you could base on a range of float or integer, or a list of string. And then you would at the end you would want to see how do you want to collect those metrics. In this case, we just use the normal standard out. So we just look for a keyword. In this case, we look for the validation accuracy keywords for the accuracy and treat that as the metrics. And then at the end, we'll just pick a config map that we use. So by default, we just use the trials template. And then any custom template you want to use, we can also select it from here as well. So with the default setting, we'll just click on deploy. You will see a experiment have been successfully submitted. And then we could go ahead and click on this tab again and click on monitor. And you will see like a new experiment has been triggered. And you could click on here to see like what kind of information you have submitted for this experiment. So you could see like the parameter you're tuning, the objective of this experiment, the algorithm you use, and the template you have used in this case. And then if you have anything running, you will be able to see the suggestion for each of these runs. Since like we are running 12 trials, so it's probably going to take 5 to 10 minutes for it to finish. So I'm going to show you one of the completed experiment. So once the experiment is complete, it will show you like a graph saying like how these hyperparameters are mapped together. And you can see like with accuracy mostly above 0.9%. I mean, mostly over 90%. They have like LR and number of layers all over the place. And there's only like one experiment is sort of like failing to get a high accuracy in this case. So and that has like you can see what kind of hyperparameter is being used for this training. And then at the bottom you could see like each trial runs and like what kind of hyperparameter they use for these trial runs and the accuracy and the status. And when you click on each trial run, it will show you over time, like how the accuracy have changed. Like let's say you have multiple epochs, you could just set it, let's say like 10, at the time of 10 epochs, what's the accuracy at that? When you add more iterations, how the accuracy has been changed over time. And you could also put like loss rate in this case as well. Like you want to minimize a certain parameter, you could put like loss rate and then see how it could minimize over time instead of maximizing the accuracy. So that is like a very simple overview. And for any template you have used, you could find it under the trial templates. Over here, you could see how the job is being defined. So usually you will use the dot trial to replace it with the trial name, and then dot namespace to replace with the namespace. And then for each hyperparameter you want to tune, you say you define it as dot name and then dot value. Then inside the parameter form, you could just add extra parameter you want to tune inside there. So I think that's like the very high level view of Knative, and we'll go over like more details in tomorrow's sessions. So is anyone have any question at this point?
I don't see any questions in the chats.
Yeah, so probably it would take a while to run. So if anyone's seeing any progress or have encounter any issue, just let us know. So you should be able to see like at least maybe 2 or 3 trials being finished. So you should be able to start seeing some feedbacks of the hyperparameter tuning, and you should be able to start tracking like how it runs over time as well.
That's very exciting.
Yeah. Any question regarding to this, or is everyone still like waiting it to run? Yeah, it will take a while. It will take 5 to 10 minutes because it will run like 12 trials. Yeah.
It's incredibly exciting, Tommy, because the team I work with have spent 18 months manually defining the hyperparameters and running experiments over that 18 months to see if they can alter them.
Great.
And it's good to see this being automated and productionalized.
I see people are running it. That's great. So if you have like any like question regarding to the algorithms, you can always go to the GitHub page and check it out. There's like more detailed guide on how to get started. And we will explain it in more details on how you could like write each YAML file in tomorrow's sessions.
That's great. Is
Yeah.
there homework to give to people?
Thanks. So I mean, while we're waiting, I will just show you like the rest of the components. So the artifact store is what you have been seen in the notebook. This is based on the metadata server inside Kubeflow, where all the artifacts you have produced is being tracked over here. So you can also visit it inside the pipeline page as well, but it's also in the main Kubeflow dashboard. And then underneath, you have like managed contributors. Because we're technically running a single user mode, so you're probably going to see just one user, anonymous, and then the namespace you own under this user. And I mean, in this case, you could add more contributor, but for what single user mode, since there's no authentications, you still get into as anonymous by default. And if you run it with multi-user, you're able to see there's more buttons for you to manage which user have access to a particular user namespace, and you could assign them as writer or reader. And then below that, it's just a GitHub link to the Kubeflow Kubeflow GitHub page and the documentations. So any question regarding to like Khatib and artifacts or like how to manage user?
I think we are probably good, Tommy. Thanks. This was an excellent session and an excellent walkthrough, right, with I would call the Kubeflow dashboard. For folks who would want to retain their environment, or as well as the dashboards we have given for tomorrow, definitely please feel free, try out different things. If you break it, no worries. But we can try and get it deployed again, right? So I think that probably calls to the end of the day, right? And the good thing is we have been addressing a lot of the questions while going through the sessions themselves. So I'm hoping there are no more outstanding questions, right? But if there are, definitely feel free to bring it up right now, or you can continue using the Slack channel, because the chat here will be lost. Hopefully, Susan, you will be taking.
Oh, of course, nothing gets lost.
But yeah, thanks. And tomorrow, I think we will be doing focusing on these three areas, which is the pipelines, where it is, what it is, and hopefully shining some light on where the projects are going as well, in terms of the roadmap, KF serving, and the third one, right, the distributed training operators, as well as the CATIV, which is a hyperparameter optimization. Now, as I said, beyond that, there are definitely other components in Kubeflow, like for example, Feast. There is a Spark operator, right? So if you do need more info on any of these things, please let us know. We typically don't tend to use some of those things, right? We can definitely if we don't have deeper insights, we can connect you with the right folks there on that side. And similarly on the case for if you do if you're running, or if you do plan to run any of these things on OpenShift, right, please reach out. If you do want to extend and run it with Open Data Hub, like the initial demo we had earlier in the morning, using Apache Superset, PostgreSQL, Kafka, all which come as part of the Open Data Hub, but you essentially have the same deployment and management experience as Kubeflow. So now you start extending and you start getting a much more full-featured data and AI platform, right? So if there are any questions on that side, also definitely feel free to bring it up.
Right. So there are some questions in the chat. So someone's running their Kubeflow cluster on Minikube. They want the best way to shut down the cluster on Minikube.
Shut down the Minikube.
Shut down what?
But
no, Minikube stop, right? Or something else. I'm not sure what you mean by shut down the.
I think probably what he is asking is, whether we need to first, is there like an incremental thing, you first shut down the Kubeflow and then shut down the Minikube? I think, yes, so as you mentioned, Wishing, the best way is just do Minikube stop.
Yeah, Minikube stop. You don't want to delete it. You just run Minikube stop, and tomorrow you can run Minikube start. Usually that's to get back all the stuff that you have right now.
Do I need to stop the pods?
No, you don't.
No, okay. No. And then there was someone asking about steps and instructions for Khatib hands-on.
So that's for Tommy. I'm not sure, Tommy, I don't think I also saw the CATIB hands-on instructions. Maybe that's something you might need to update.
Yeah, sure. I for this hand-on, it's mostly from the dashboard. I could update an instruction for that as well.
Yeah, please. I mean, I think you should. Good enough. So if there are missing links to that, right, just revisit that and update that walkthrough. More than the hands-on. Oh, okay, now I get it. I mean, the question is more around a hands-on lab on CATIB. This was more of a walkthrough, right? And hopefully that gives you some sense of the hands-on, but we don't have a deeper dive session which is just dedicated to CATIB and step-by-step, like, dedicated hour for that. But again, as I said, right, I mean, please send us your request if there are areas because of the time restrictions we wouldn't be able to cover, right? I mean, there is, always we can schedule a follow-on, whether it's on OpenShift, whether it's with Open Data Hub, whether it's, a deeper hands-on on CATIB or Spark or Feast, right? Yeah.
So I have a question. How do you think that the recordings that you made and published differ from these live recordings that we've just made?
So none of the hands-on sessions were recorded, right? So this is the first time, or even the walkthrough which Tommy did, this was not recorded.
This was not recorded. Okay. Okay. So that's definitely one difference. Okay.
And even the opening session I gave, that wasn't recorded, right? So there is, I mean, hopefully, once we have the recordings from this, Susan, we will update the links here. Now, the individual sessions on Kubeflow pipelines or KF serving or distributed training and hyperparameter optimization, they are recorded, right? Now, the only thing is we will probably be adding a bit more customization based on some of the questions we got today. So that will probably feed into that, right? So for example, somebody, asking around the multi-user story around Kubeflow pipelines, or in general, the next beyond Kubeflow pipeline 1.0, the roadmap for that, right? So some of those customizations will go in the live sessions tomorrow, but for the most part, right, I mean, if you do want to follow them virtually, they are recorded, they are there, and you can do that as well. Yeah.
Okay. Okay. Well, I'll be posting these recordings anyway, and I'll give you everyone the links in Slack, and then you can put them on the GitHub.
If possible, can I quickly go into the use cases for Kubeflow again? Because I think Animesh already answered most of this, but I'm asking myself what I should use this for and what I shouldn't use it for. So what the real scope of Kubeflow is. And I think I understood it's extremely useful to train individual models, right? If I have some data science problem, let's say for an insurance company, and I want to have a single risk model that I want to compute, it's perfect for that, and it can also do the neural architecture search and hyperparameter optimization and so on. And if I had multiple models, that's why I mentioned the insurance case, oftentimes you have like 3 or 5 or whatever models that work closely together. I could also build a pipeline for that and retrain them. But there are 2 cases. On the one hand, when I have a whole life cycle to take into account, let's say I also have to harden the model, and I have to just do things like this, look at the bias and so on and so forth. That I assume is also covered. But when I start actually collecting more data, and then I have to clean that data and annotate it and so on, at what point would I stop using Kubeflow and would have to go to Open Data Hub? And then finally, when I have very complex AI systems that also take actions in environments where, for instance, agents, let's say dialogue systems, I have bots that can actively answer something and that learn based on what the user says about, for instance, what the user likes and doesn't like and recommendations, or also to adapt to my speech better and understand me better. Can you give me a better idea of when I would stop this? Like, for instance, for a robotics system where I have all kinds of visual components that I constantly need to update that works against a simulation or so, I assume I probably wouldn't use Kubeflow. So when would I use it? When wouldn't I use it? And when would I use Open Data Hub in addition to it?
Great, Fog. That's a lot of questions in one question, right? So I think let's come to this slide, right? Which I shared in the morning. One of the things, right? So I think when you look at the machine learning, end-to-end machine learning platform, right? So when you're talking in terms of the platform, what should the platform provide you, right? So capabilities to build your models, train your models, do hyperparameter optimization, neural architecture search, deploy your models, right? And hopefully, then go and give you a technology to, if you want to orchestrate and automate all of these through workflows, through pipelines, right? And allow lineage tracking, provenance tracking, artifact tracking. That's all built in. Now, there is a second layer, right? And as the first part of your question was, okay, now we are going into the data part of the life cycle, right? So feature engineering, schema generation, ETL, right? Those are the capabilities not natively, which are strengths of Kubeflow. Now, can you use Kubeflow to write custom components to do some of these things? Yes. More so, Kubeflow pipelines, which essentially the more and more usage of Kubeflow pipelines in the industry is with a lot of custom components, right? So custom components, I mean, if you see, there are pipelines which are running all over the AWS SageMaker portfolio, Azure ML portfolio, in our case, the Watson ML portfolio, which are not leveraging the core native Kubeflow components for training or hyperparameter optimization or serving, but they are using the native functionalities coming from those cloud providers and the products they have. Now, specifically on the data side, right? I mean, if you're doing more and more ETL, then you probably want to use something like Airflow, right, to orchestrate those Airflow jobs, right? So that's where you will transition and get more by deploying Open Data Hub components as part of it, right? Similarly, if your requirement is to have relational databases, have querying mechanism over your Hadoop ecosystem, then again, those are the capabilities which you will go and look into the Open Data Hub ecosystem, right? Data analysis using Superset, again, part of the Open Data Hub ecosystem, Kafka. So that's where it transition. Now this covers the platform part of it, right? And now the third case which you're bringing up is, the higher level, what we call AI applications, right? So for example, when you look at the Watson portfolio, beyond Watson Studio, Watson Machine Learning, Watson OpenScale, Watson Knowledge Catalog, the upper layer is AI applications or AI services, right? Which are pre-built systems like Watson Speech to Text, Watson NLU, right? Watson Discovery, which are applications which use AI, like they will use a platform like this under the covers, right? But they are essentially AI-infused applications which solve a particular problem in that domain, right? So again, that's an area where you will use Kubeflow, but you need to bring in a very domain-specific construct into this, right? For example, if you're doing AI ops specific models which are supposed to predict your outage for your data center based on the network bandwidth or the CPU usage or GPU usage, right? So that's a very dedicated field, right? You will use a platform like this under the covers, but then you need to bring in a lot of domain-specific algorithms, etc., which you're bundling in those models. The other thing is, and maybe not in this slide, right? The second thing which I said was, we talked about this landscape, right? So obviously, if you see, there are areas like reinforcement learning, right? I mean, Kubeflow doesn't go into those directions, right? This is, again, a very specialized field. And that's where you will start looking at, go and look into the LFAI landscape. So if you need a link for that, right? And okay, let me expand it. You will start looking into projects, right, which are there, which are in open source and which play specifically into that particular arena, right? Yeah, right. So again, it's the notion, again, when I talked about trusted AI, right? Now that's not a natively Kubeflow domain, right? But KF serving, if you see, has started providing capabilities around, model explainability, adversarial detection, drift detection. We are also integrating, IBM libraries into KF serving for that. but that's not a native, domain, that overall trusted AI. There is a lot more which can be done there, right? So there are individual projects which are handling specific areas onto that side. So yeah, my answer would be, beyond when you're looking at an end-to-end platform to give you the tools to build AI applications, a combination of Kubeflow and Open Data Hub gets you, 80% of the way. From there onwards, more domain-specific fields, whether it's robotics, reinforcement learning, you need to start going into, the more domain-specific projects in those.
Yep, perfect. That provided a lot of clarity. Highly appreciate it.
Thanks. Yeah, so if somebody wants to have this, both the links, this is the link for the landscape here, and I will ping the Open Data Hub link as well. You can look at the components which are available in that reference architecture, and then,
Great. So have we ended for today?
Yes, we are at the end of the